An airplane is flying on a path that will take it directly over a radar tracking station. If S is decreasing at a rate of 400 miles per hour when S is equal to 10, what is the speed of the plane? All right, so you have a little bit of the figure here already sketched off for you. Of course, this here is going to be our radar, and this is our plane. Now, the fact that it says that it will be flying over the radar station, that's why I've put the arrow indicating it's going to have to come this way. Because if I put my radar here, my plane would have to be coming this way in order to fly over it. Now, you weren't told in the problem that the distance from the ground to the plane, of course, they just have it labeled as 6, but it would be 6 miles because S is given to us in miles. Sometimes the problems will just tell you that, and like in this case, you already have a portion of the picture drawn, and you would know from the picture that that is 6. Now, this would be, and I mentioned this earlier about sometimes you have values that will not ever change, and if you have values that won't ever change, then you can actually substitute those in before you do your differentiation. And that's going to be the case that you see here. Like going back to the pile of sand that we just finished, you know, you were told that the height was 15, but the height of that pile of sand was constantly changing. So if it's something that's constantly changing over time, you can't substitute those in until after you've done your differentiation. But this plane is 6 miles off the ground. As this plane flies this way, this distance from the ground to the plane is not ever going to change. It's always going to be at 6. That's something that's constant. But now S is going to change because as you move your plane, let's say to this location, and you were to get the distance from there to the radar station, then S would actually end up being a smaller value at that point. So see, that's something that's constantly changing. Okay, so let's talk about, again, our given and our find. All right, it says if S is decreasing at a rate of 400 miles per hour. So that means the distance from here to here is decreasing at 400 miles per hour as the plane comes here. So I'm going to refer to that as ds dt. Of course, I'm picking S because this distance here was already labeled for you as being S. Now, that rate, as it said, is decreasing at a rate of 400 miles per hour. You actually need to identify that as negative 400, and that's because that it is something that is decreasing. So that's one thing that you'll see me talking about of these next few problems. Like if you think back to the problem that I just finished working about the pile of sand, and you're talking about the rate of change of the height of that pile of sand was increasing. You know, it was getting taller and taller and taller. Back even before that problem, we had the balloon, you know, that was being filled with air. Well, again, that would be something that would be positive because as you fill your balloon with air, it's getting bigger, okay? So this time we've got something that's decreasing, so you do have to have a negative value to represent that, okay? Now, you are also told that S is equal to 10. All right, what you're trying to find, it says, what is the speed of the plane? Now, of course, the plane's up here, but whether you're talking about the plane being located here or down here, I mean, of course, the distance, like from here to here, would be the same as the distance from here to here. So what I'm going to do is, using the picture that we already have drawn off here in the right triangle, like instead of coming up here and labeling something, this being the same as this down here, I'm going to label this as being my X, because as it moves from here to here, that's what's going to represent that speed, okay? So that means I'm going to try to find dx dt. Now, you had a choice on what you wanted to use for that particular variable. Okay, so the equation that you're going to need to use here is going to be your Pythagorean theorem. I didn't draw the little box in here, and I should have, but I mean, what you're dealing with is a right triangle. Therefore, your equation's your Pythagorean theorem. All right, so your Pythagorean theorem, of course, is a squared plus b squared equals c squared. So, of course, putting it in terms of what we have here. Now, a and b, doesn't matter which one is which, that's going to be your two legs. So this is going to be x squared plus 6 squared. Okay, like I said, you're allowed to, even though I've not done the differentiation yet, I'm allowed to put in my 6 at this point because this distance doesn't ever change. The s changes and x changes. I mean, as this plane flies this way, this is getting less, okay? Now, of course, the hypotenuse is what we're using s for. Okay, so doing your differentiation with respect to time, this would be 2x dx dt. Now, the derivative, of course, this is 36, but the derivative, of a constant is just 0. So actually, there's no need to say plus 0. I'll just mark out the plus sign and just go ahead and bring down my equal sign. Power rule here, so this would be 2s ds dt. Okay, now we're trying to find dx dt. So I don't have anything to plug here. That's what I'm trying to find, which means I need to have an x. Well, look at your given information. I don't have an x up here, so we'll have to talk about that. I do have s, that's the 10. I do have ds dt, that's the negative 400. Now, this is a situation, though, in which you actually can find x. You don't have to rewrite your formula like we had to just a few minutes ago. Using your Pythagorean theorem, remember you've got the x squared, of course 6 squared is going to be 36, I'll go ahead and do that, and that's equal to s squared. Well, you're wanting to know this rate of change specifically when s is equal to 10. So you can substitute in the 10 for your s, and of course you already have this value, which means that will give you the opportunity then to be able to figure out what x needs to be. So I have x squared plus 36 would be equal to 100, because that would be the 10 squared. So x squared is equal to 64. So x would be equal to plus or minus 8. But back up here on the given information, you actually would just use x equal 8. You wouldn't do the negative. Okay. So x is 8. Of course, we're trying to find dx dt. S is 10. And ds dt is negative 400. Okay, so that's going to give me 16 dx dt. And that would be equal to negative 8,000. So dx dt is going to be equal to negative 500 miles per hour. Now, the fact that it came out to be negative ought to make sense based on what I was explaining a while ago, because as the plane, let me get my picture down, as the plane flies this way, remember s is going to be getting shorter, but x is also going to be getting shorter. So, or the distance is going to be less. So that's why that comes out to be negative, because it is something that's decreasing. Now, because the problem specifically said, though, what is the speed of the plane? I mean, when you're describing the speed of something, that would actually just be the absolute value of this. So, like if you're checking your answer, in the back of the book, you would actually only see 500 miles per hour. And like I said, that's because of it specifically said speed.